Hello, this time I'm going to explain the homework problems from section 5.2 of Pearson Precalculus. There are about 20 problems to go. Section 5.2 is about one-to-one function and inverse functions. Okay, so let's start. Okay, first problem is for the function on the right, determine whether the function is one-to-one. So this function is not the one-to-one function because on the range, the Catherine is corresponding to two different outputs in the domain, Scott and Alex. So the answer is no, this is not the one-to-one function. Number two, for the function on the right, determine whether the function is one-to-one. It seems like the same question to me. So the answer is no. The order is different. Okay. Okay, now the function is written in different way. So is it a one-to-one function? So 4 corresponding to 9. 3 is also corresponding to 9. So immediately we can see it's not a one-to-one function because there are two different inputs corresponding to the same output. So it's not a one-to-one function. Okay, next one, this is 19, but for question 4. So 4 corresponding to 4, 5 corresponding to 5, 6 corresponding to 22, and 7 is corresponding to 91. So for each value in the range, there is only one value in the x corresponding to that. So this is a one-to-one function. Okay. Now, next question is whether the given function on the graph is a one-to-one function. Okay, so there are infinitely many points, unlike the previous problems. So we have like a bunch of points like this. And what we need to check is for each value in y, there is only unique value in x corresponding to that y value. And to determine whether the given graph shows a one-to-one function or not, you can use a technique called the horizontal line test. Horizontal line test. Okay, so draw the horizontal line. And if you see that the horizontal line passes the curve, meet the curve at only one point for any horizontal line like this, then it is a one-to-one function. So since this is a monotonically increasing function, this only has a y intersections at most with the horizontal line. So it is a one-to-one function. Okay, so this is not the one-to-one function because a horizontal line can meet the parabola in two different points. So it's not the one-to-one function. Okay, so this is, again, it's one-to-one function because it's monotonically increasing. Okay, now next question about the inverse function. Question number 8. So the graph of a one-to-one function f is given. So the function looks like this. It's monotonically increasing. So it is a one-to-one function as it passes the horizontal line test. So it has an inverse. The inverse of the graph must be symmetric with respect to the line y is equal to x. Okay, so if this is a given function, one-to-one function, then its inverse must look like this, symmetric with respect to the original function. I mean, by the line y equal to x. So looking at the symmetry, choice A and choice C looks like the best, but C is slightly not symmetric. So choice A would be the best choice for us. Okay, same thing. This is graph looks like this. So the original function is a one-to-one function like this. And so it has an inverse function. And inverse function must looks like should be symmetric with respect to this one. So somewhat similar, might be slightly different. So maybe something like this. So the choices would be like choice A would be the best choice. Do you see the red line and the blue line intersect along the line y is equal to x? Otherwise, it doesn't make sense that, for example, part D does not make sense because if they meet at this point, they also have to have a same intersection on the symmetric point around here. So D is not correct. Likewise, C is not correct, and B is also not correct. And the choice A is only one. Okay, number 10. So consider the function fx is equal to 5x plus 1. And the gx is 1/5 times x minus 1. So part A is to find the composition of two functions f of g of x. That is equal to f of 1/5 x minus 1. So that's going to be 5 times the input, 1/5 x minus 1 plus 1. 5 times 1/5 can canceling each other. So you're going to get x minus 1 plus 1, which will be equal to x. Let's do part B. So g of f of x, which is g of 5x plus 1. So this is the input into the g function. So it is 1/5 times input 5x plus 1 minus 1. Simplifying the inside of parentheses, it's going to be 5x. So that is also equal to x. From part A and part B, since the composition of f and g is going to give you the identity function, which means the input is equal to output. So they are inverse of each other. So it's going to be like x. So this is talking about domain. Since both of them is a linear function, since both of them are polynomial, there is no restriction on the domain. Okay, so this is also equal to x, and the domain is everything. Okay, are they inverse to each other? Yes. Okay, so this is like a same question, but a fraction, rational expression. So let's say f of g of x, this is question 11. That is equal to f of g of x is equal to f of 4 over x, which is 4 over input. This is a fraction inside a fraction. Let's multiply top and the bottom by x. So the numerator becomes 4x, while the denominator becomes 4. So that's going to be reduced to x. There will be a domain restriction. This looks like we can put anything, but here denominator becomes 0. So x shouldn't be equal to 0. Okay. So the answer is x. Now we have a domain restriction, x cannot be equal to 0. Okay, and g of f of x should be same because f and g are identical functions. So I'm going to just copy the same answer here. Okay, since the input is equal to output for both f of g of x and g of f of x, so because this is equal to x for every x, and g of f of x is also equal to x for every x in the domain, they are inverse of each other. Okay, so again, it's going to be just a similar question, but the more complicated expression. So let's say f is 5x plus 8 over x plus 9, and gx is 9x minus 8 over 5 minus x. So f of g of x is equal to f of 9x minus 8 over 5 minus x. Plug in this one into the function of f. It's going to be 5 times input plus 8, and the input plus 9. Fraction inside the fraction. Let's multiply top and bottom by 5 minus x. Use the distribution. The first term in the numerator becomes 5 times 9x minus 8. Second term becomes 8 times 5 minus x. Do the same for the denominator. The first part, 5 minus x is canceling to each other. You get 9x minus 8. Second term is 9 times 5 minus x. Simplifying the numerator, it's gonna be 45x minus 40 plus 40 minus 8x. Denominator is 9x minus 8 plus 45 minus 9x, which is equal to 37x over 37, which is equal to x. Now, domain will be any number is okay, except that this is becoming 0. So x cannot be equal to 5. Also, this part shouldn't be equal to 0, but that will never become 0. So the only restriction will be x is not equal to 5. Okay, so the answer is input is equal to output. And this is everything except 5. Okay, g of f of x. It's a computation will be about the same, so I'm going to skip this, but it's going to be x. And any number except negative 9 would work. So they are inverse of each other. Okay, number 13. The function f of x is equal to x cubed plus 1 is a one-to-one function. Indeed, it is a one-to-one function because y is equal to x cubed is a monotonically increasing function, and this is just adding 1. So it is a one-to-one function by horizontal line test. Now we are going to find the inverse of that. So let's find the inverse. The inverse relation is replacing x and y. It's going to be x is equal to y cubed plus 1. You are going to solve for y. So it's going to be x minus 1 is equal to y cubed. To remove the cube, since we are working with the real numbers, you just need to take a cubic root both sides of the expression. So y is equal to cube root of x minus 1. So cube root of x minus 1. Cube root, no, it doesn't work. Cube root, no, it doesn't work. Okay, n root. So I had to type like this, nRT. Then I'm gonna put 3 here, and it's x minus 1. Okay, domain is all real number. Yeah, domain for the function f is a polynomial, so it's all real number. And the range of f is also all real number because graph is coming from negative infinity to positive infinity in this cube powered function. Okay, now find the domain of f inverse. Domain of F inverse is same thing as the range of F. Okay, so it is also all real numbers. Now the range of F inverse is equal to the domain of the original function. Okay, when F and F inverse have a kind of swapping the domain and range. In this case, everything is all real numbers anyway, so it's gonna be all real numbers. Okay, now the graph, looking at the choices. So the blue one seems to be very small. I cannot see it. Blue one looks like a cubic function, and the pink one should be its inverse. They must be symmetric with respect to the line y is equal to x. So the choice B is not symmetric. Choice C is not symmetric with respect to this dotted line. Choice D is also not symmetric. So the only choice seems to be A. Okay, now this is just simply computational problem number 14. Assume the function y is equal to 4x over 7x minus 1 is 1 to 1. So let's find its inverse. So the inverse is x is equal to 4y over 7y minus 1. Yeah, inverse relation is you flip x and y. You are going to solve for y. Multiply both sides of the expression by 7y minus 1. Expand left-hand side of the equation. We are going to solve for y. This is a linear equation in terms of y. So move 4y to the left side, move x to the other side, factor y out. So the y was the inverse. The output of the inverse function should be x over 7x minus 4. Okay, so it's going to be x over 7x minus 4. Okay, now domain of f is just looking at this expression. Domain of the function is any number except a value which makes the denominator 0. So everything is okay except 1 over 7. Now the range of f is same thing as the domain of the inverse function. So anything except 4 over 7. Okay, anything except 4 over 7. The domain of f inverse is same thing as the range of this original function. So I need to find the domain, range of the original function. To find the range, it's better graph this one. So let's graph this function. So the denominator is 0 when x is 1 over 7. They're going to be a vertical asymptote. Since both numerator and denominator is degree 1, that ratio of the leading coefficient is going to be the horizontal asymptote at 4 over 7. X-intercept is equal to 0. So the graph going to be looks like this. Okay, looks like this. So y value could be anything except 4 over 7. So domain of f inverse is same thing as range of f, which is I already wrote down with everything except 4 over 7. Except 4 over 7. Okay, and the range of f inverse is same as domain of the original function, so everything except 1 over 7. Okay. Now we have number 15. We have a function fx is equal to x squared minus 16 over x squared times 8 for x strictly greater than 0. Okay, so we can assume this is a one-to-one function. Let's find the inverse first. So its inverse is x is equal to y squared minus 16 over 8y squared. Let's solve this one for y. Multiply top side and both sides by 8y squared to get this. So it's going to be 16 is equal to y squared minus 8xy squared. Combine these like terms, combine and factor them by y squared. Divide both sides by 1 over 8x. Okay. Since x is positive in the original expression, in the inverse relation, y must be positive. Okay, so after you taking a square root, since y is positive, you are only going to take positive square root of the expression. So it is square root of 16 over 1 minus 8x. You can put 16 out of the square root. So it's gonna be 4 over square root of 1 minus 8x. Okay, think about the domain. So domain, it's already stated here. Domain is x is greater than 0. Range of f. The range of f will be hard. So this function is kind of hard to understand, but since x is positive, this is positive. So let's make a substitution. The graph looks like this. So it has a vertical asymptote at x is equal to 0 and horizontal intercept at 16. And since both of them are linear term, looking at the leading coefficient, the horizontal asymptote is at 1/8. Okay. So when x is 0, or as x is getting closer to 0, looking at the, it's going to be negative values. So I can kind of guess it's going to be negative here and positive later and getting closer to 1/8. So the range seems to be everything below 1/8, everything below 1/8. So y must be everything below 1/8. Now domain of f inverse is same thing as range of the original function. So I'm gonna just copy the previous answer. Someone else. And the range of f inverse is same thing as domain of the original function. So y should be greater than 0. Okay. Next one is a parabola. It's a quadratic function. So in general, quadratic function does not have an inverse if you take the domain to be all real numbers. Let's take a look at the graph of this. It's going to be 6, 8 is the vertex, and it's moving this way. This is not a one-to-one function since the domain is everything. It fails the horizontal line test. However, if you add the condition x is greater than or equal to 6, you're only looking at this part, and this part is monotonically increasing, and so it is a one-to-one function. Okay, let's find the inverse. Inverse is flip x and y. It's going to be like this. So it's going to be y is greater than or equal to 6. Okay, move 8 to the other side. So for y, multiply both sides by 16. Remove the square and add 6. When you remove the square, you're gonna get plus minus. However, since y is greater than 6, this should be positive. Okay. So y is equal to 6 plus 4 square root of x minus 8. Okay. So it's going to be 6 plus 4 square root 4 square root x minus 8. Domain is any number greater than or equal to 6 as indicated in the program. Range is everything greater than or equal to the vertex y value, which is 8. The domain of the F inverse is same thing as the range of F. So I'm going to just copy this one. So it should be greater than or equal to 8. Range of F inverse is same thing as domain of the original function. So what is domain of the original function? It is greater than or equal to 6. So y is greater than or equal to 6. Okay. Number 17. Suppose f of 2 is equal to 5 and f has an inverse function. Then what is f inverse of it? Basically, you input both sides of the equation into the f inverse. Now, f and f inverse is canceling each other. You're going to get 2 equal to f inverse of 5. Yeah, idea is like this. So function send 2 to 5. So its inverse should send 5 to 2. So the answer is very simple. It's going to be 2. Now the domain of the one-to-one function is 6 through infinity and range is -7 to infinity. Okay, so what is the domain of f inverse, which is same thing as the range of the original function. So it's going to be -7 through infinity. Range of f inverse is same thing as domain of the original function. So it's going to be 6 through infinity. So it's going to be the same problem. So I'm just going to write down the answer. Domain of the inverse is same thing as oops. Oh, domain of the inverse is actually, sorry, it should be range of the original function. Oops. Okay, so domain of the G inverse is the range of the original function. So it's going to be 5 through infinity. Yeah, I should have copied the answer. So -infinity to 0 for this one. Okay. Find the inverse of the linear function. Okay, so there's a word, it's a letters included. So you have start with y is equal to mx plus b, m is not equal to 0. So whose inverse is x is equal to my plus b. Move b to the other side of the equation, then divide both sides by m, which is well defined because m is non-negative. Okay, so that's the f inverse of the function. It's another linear function, also it looks more complicated. Okay, so I thought I was doing problem 18, but for some reason it's done. I guess I didn't count it correctly. Well, that's complete explanation for section 5.2, which is about the one-to-one function and the inverse function. So see you next time.